Rolls-Royce has built the largest jet engine ever, the UltraFan, with a diameter of 140 inches. This engine isn't just big, it's revolutionary. It's designed to be 10% more fuel efficient than Rolls-Royce's most advanced engines, like the Trent XWB, while offering up to 85,000 pounds of thrust. But how does increasing the size of the engine help reduce fuel consumption? And could this technology reshape the future of aviation? The UltraFan is more than just a larger engine. It's a leap forward in aviation technology. Rolls-Royce began testing it in 2024, and its key feature is its geared turbofan system. Unlike traditional designs, this system allows the fan to spin at optimal speeds, independent of the turbine, significantly boosting fuel efficiency. The result? A 10% improvement over the Trent XWB engine that powers modern long-haul aircraft. Additionally, the carbon composite blades used in the UltraFan make the engine lighter without sacrificing strength. This weight reduction is critical for minimizing fuel consumption, especially on long-distance flights. For airlines, this could translate into substantial savings. But how quickly can they adopt this groundbreaking technology? The focus on sustainability is a defining element of the UltraFan. In 2023, Rolls-Royce demonstrated the engine's ability to run entirely on sustainable aviation fuel, SAF, made from renewable sources like waste oils and agricultural residues. This achievement is crucial for the aviation industry, which is under increasing pressure to reduce its carbon emissions. But how far can SAF take us in the journey to decarbonize air travel? By cutting NOx emissions by 40% and reducing particulate matter, the UltraFan sets a new benchmark for cleaner aviation. The goal is for engines like the UltraFan to play a vital role in achieving net zero targets by 2050. Rolls-Royce estimates that 80% of aviation's future fuel needs could be met through SAF, combined with more efficient engine designs. But will the availability of SAF be enough to meet the demands of the growing airline industry? What truly distinguishes the UltraFan is its planetary gearbox, which handles an extraordinary 65 megawatts of power, enough to power an entire small city. This gearbox allows the fan and turbine to operate at their most efficient speeds, something not possible with conventional engine designs. It's this innovation that makes the UltraFan not only large, but also incredibly efficient. Beyond the gearbox, Rolls-Royce's use of 3D printed parts in the engine represents a significant shift in how jet engines are manufactured. This process enables the creation of lighter, more complex parts that would be difficult or impossible to produce using traditional methods. With lighter parts, the overall efficiency of the engine improves, which is critical as airlines seek to lower both operating costs and emissions. Rolls-Royce isn't stopping at the UltraFan. The company is exploring how the core technologies of this engine, like the geared turbofan and composite materials, can be applied to other engines and even next-generation hybrid electric aircraft. As aviation looks toward alternative propulsion methods, Rolls-Royce's work with hydrogen combustion and electric powertrains is paving the way for future breakthroughs. By creating an engine that can run entirely on 100% SAF and exploring hybrid electric power systems, Rolls-Royce is preparing for the next phase of aviation. Could the UltraFan be the stepping stone toward fully electric commercial jets? For airlines, the UltraFan is a strategic solution to growing economic and environmental challenges. By reducing fuel burn and emissions, the engine offers a way to lower operational costs while meeting increasingly stringent environmental regulations. Rolls-Royce expects that by 2030, aircraft powered by the UltraFan will be in commercial service, delivering longer range and lower fuel consumption. But how will this affect global competition among airlines? Carriers equipped with UltraFan engines could gain a significant advantage in terms of fuel savings and reduced carbon taxes. Will this force other engine manufacturers to accelerate their development of next-generation engines, or will Rolls-Royce dominate this space for years to come? The global aviation industry is being shaped by a wave of environmental regulations aimed at reducing carbon emissions. The Paris Agreement, signed by over 190 countries, puts immense pressure on airlines to reduce their environmental footprint. To meet these ambitious goals, innovations like the UltraFan are becoming critical. But how will these international policies drive the adoption of sustainable aviation technologies? In the European Union, for example, Fit for 55 targets a 55% reduction in greenhouse gas emissions by 2030. Airlines operating within this framework are increasingly turning to innovations like sustainable aviation fuel and fuel-efficient engines to meet these requirements. The UltraFan's fuel savings and ability to run on 100% SAF make it a viable solution in regions where governments are imposing strict carbon limits. Could these regulations also force global competitors to follow suit, speeding up the adoption of greener technologies worldwide? In contrast, other regions like Asia and North America are moving at different paces when it comes to environmental regulations. Will airlines in these regions be slower to adopt new technologies, or will global environmental trends push them into faster action? The UltraFan is not just about immediate fuel efficiency, it's about preparing for a future where sustainability is non-negotiable. As airlines face increasing pressure to cut their environmental footprint, the UltraFan provides a solution that addresses both economic and ecological concerns. With the aviation industry set to double in size by 2040, innovations like the UltraFan are essential for balancing growth with sustainability. However, the success of this engine depends on how quickly the aviation industry can adapt. Can airports and fuel suppliers keep up with the demand for sustainable aviation fuel? Will airlines make the investments necessary to retrofit their fleets with UltraFan-powered aircraft? As one of the leaders in aviation technology, Rolls-Royce is positioning itself at the forefront of the industry's transformation. The UltraFan marks a significant step toward reducing the aviation sector's reliance on fossil fuels. But the question remains, how quickly can the entire industry shift to more sustainable solutions? And will Rolls-Royce's competitors keep pace? The UltraFan represents more than just an engineering achievement. It is a blueprint for the future of aviation. Its combination of size, efficiency, and sustainability is unmatched, and as it moves closer to commercial use, its impact will likely be profound. Rolls-Royce has taken a bold step toward transforming air travel, but the journey is just beginning. In my view, the UltraFan is a clear signal that the future of aviation will not just be about flying faster or farther. It will be about doing so in a way that preserves our planet. As we approach 2030, the question is no longer if engines like the UltraFan will power the next generation of aircraft, but how soon will they be fully integrated into the global aviation landscape? The clock is ticking and the world is watching.